In Chapter 8, we're going to start dealing a lot with polynomials. You've heard me use the term monomial and binomial a lot this year, and now you're going to start to hear even more terms that are similar to that. Just a quick reminder, a monomial means one term. A polynomial means more than one term, several terms together. And then there's special types of polynomials, like a binomial is two terms, trinomial is three terms, which we'll talk about more. So today, first thing we're going to look at is finding the degrees of a monomial and the degrees of a polynomial. Very easy to confuse these, so you really have to memorize the difference between the two. When you're looking at the degree of a monomial, you're just going to add up the exponents of the variables. When you're looking at the degree of a polynomial, you're going to look at the degrees of every monomial in that polynomial. So every term within that set of terms. And the one that has the largest degree is the degree of the polynomial. So you're never going to add every single set of terms together. You just take the one that's the largest, and that's your answer. Write this down, hit play when you're ready to go through some examples. Here are 4 examples that we're going to go through to find the degree of each of these monomials. Notice each of them is only one term together. Write those down, and then let's go through them. So if we're looking at 2/3 x, all we're doing is adding up our exponents of our variables. There's only one variable, and the exponent that goes with that variable right there is actually a 1. Remember, there's an imaginary 1 there. We just don't always write. So the degree is 1. On this one, and you always want to write that it's your degree you're finding, there's a variable, I add up my exponents, I have 2 plus 3, and that is 5. So my degree of that monomial is 5. Here, I have no variable, so hopefully most of you know that means your degree is 0. And if you think about it, we could have an x to the 0 power there, and it would just become a 1. And this last one, our degree, add them up. Don't forget about the 1 here. That's why I put that example in. 1 plus 6 is 7. Now, if all 4 of these terms were being added together or subtracted from each other, then what you would do is you would look at the degree of each individual term and you would pick the one that was the largest. So if all of these were being added together, then our largest degree for that polynomial would be 7. You wouldn't take all your answers and add them up. It'd just be 7. Let's try one of those examples now. Now we're looking at finding the degree of polynomials. Notice there's more than one term being added or subtracted. So this has 1, 2, 3, 4 terms being added together. So it's a polynomial. And remember, when you go to look for the degrees of the polynomial, you're going to find the degree of each term, and then you're just going to take the one that had the highest degree. You are not going to add them all together. Write that down, hit play when you're ready to go on. So, you're going to look at the first term, and you're going to add up your degrees, and your degrees are 5, because you have 2 plus 3. Your second term, the degree is 2. Third term, the degree is 1. And the fourth term, the degree is 0, because there's no variable. Notice the highest term right there was already first, and it went in order. That's called standard form of a polynomial when it's written that way, and that's typically the way you're always going to want to write your answers with these, from the highest degree down. The other way that you sometimes will look at it is from the highest of one exponent down. Notice here I have an x squared and an x squared, but then I have a y cubed. So depending on which variable you were aligning it by, you might look only at the variable. But this is standard form of a polynomial. The degree of the polynomial is 5. It's not 8. Okay, it's just 5. So you would say degree of polynomial is 5. So I'm going to go ahead and write another one, and I want you to try it. Hit play when you're ready to check it. Go ahead and find the degree of this polynomial. Once you're done, hit play to check it. So here's a term. We have one term, two terms, three terms here. This is called a trinomial, 3 terms. And if you look at it, hopefully you added this up and you got 2 plus 1 plus 1, which would be 4. 4 plus 5, which is 9, and then just a 1. If you were to write this in standard form, that term would need to come first. And your degree of your polynomial is the one that's the largest, which is 9. Before we go over the next example, I'm going to go ahead and have you write some stuff in on the left. We're going to talk about classifying polynomials, and I mentioned standard form to you already. Degrees of each term decreases from left to right. So your highest degree goes first, and it goes all the way down to your lowest degree. Write that in, and then hit play when you're ready to continue. Now, when you're looking at classifying these, you have to look at 2 things. They can be classified in 2 ways. They can be classified by their degree, but they can also be classified by the number of terms they have. Sometimes we're going to refer to things only based on their degree. Other times we might refer to them only on how many terms they have. And then for your homework, when you work on this, you're actually going to be looking at both the degree and the number of terms. So it's going to have 2 parts to its name. And I'll show you with the examples up here. Some of these you should recognize, like when you have something to the first power, when you have a degree of 1, it's a linear equation. Think about our linear equations from first semester, something like 2x plus 4. And those were to the first power. Your x and your y were to the first power. Second power, we've already talked about this a little bit, is called a quadratic, and that's second degree, or an exponent with 2. Cubic would be a third, and then we have a 4th degree. And whenever you have a 0 exponent, that's a constant, like those degrees when we were getting 0 as our answer because there was no variable. Those are the ones with the special names. Once you get above 5th degree, 6th degree, all that, you would just say it like we did 4th degree. Now, when you look at number of terms, if you only have 1 term, it's a monomial, 2 terms, binomial, 3 terms, trinomial. And then after that, you would just say polynomial, a 4-term polynomial or a 5-term polynomial. There's a chart on page 371 that kind of goes through these, again, if you need to look at it. Finish copying this down, hit play when you're ready to go over the examples. Go ahead and write this down for example 2. Hit play when you're ready to go through it. Because it's asking you to write this in standard form, you need to look at your degrees of each term. Make sure your highest degrees go first, your lowest degrees go last. If we were looking at our degrees of each of these terms, our degrees of this term 0, because there's no variable, our degree of this term 1. So this is our highest degree. It needs to go first. And you should notice that this looks similar to the way that I've been teaching you to write things this year anyway. So negative 2x would go first. Remember, the negative needs to stay with that 2. positive 5 would go second. Now my degree of 1 is first and my degree of 0 is second. The degree of this entire polynomial would be 1 because it's the highest. Now you need to look at classifying it. You're classifying it by degree and by number of terms. My degree is 1, so it's a linear, and then I have 2 terms, so binomial. This is a linear binomial. Again, I looked at the degree of the polynomial, and then I looked at the number of terms. Okay, let's try B. I have a degree of 4, a degree of 0, a degree of 2, and a degree of 4. So I'm going to write these in order. I have 3x to the 4th. This other x to the 4th needs to come forward, plus 5x to the 4th, plus 2x squared subtracting 4. 4, 4, 2, 0 are my degrees. So it's in order. Only thing is I've got like terms here. This is going to tie into our next example. When you have like terms, you need to go ahead and combine them. So when I combine these, I end up with 3 plus 5, which is 8. So now I have 8x to the 4th. Remember, these just stay like they are when you combine them. Plus 2x squared subtracting 4. Now I have it in order. I have a degree of 4, a degree of 2, a degree of 0, so 4, 2, 0. The highest degree here is 4. Remember, I'm not going to add them up, just 4. So when I look, I have 1, 2, 3 terms and a degree of 4. So this is a 4th degree trinomial. So I would write out 4th degree trinomial. Again, if you're confused about that, go look at the chart on page 371. Go ahead and write these down and try them on your own. Write them in standard form and classify them. Hit play when you're ready to check your work. So first thing you want to look at is degrees of each term. This is 2, 0, 4. Need to write it in order, so it would be a negative 9x to the 4th first, positive 6x squared second, and then a positive 7. Now I look, my degree is 4, that's my highest degree, and I have 1, 2, 3 terms, so a 4th degree trinomial. Now let's try the next one. Degree of 1, degree of 0, degree of 3. 3 goes first, so a negative y to the 3rd, then plus 3y, and then subtracting 4. Now I have it in order, 3, 1, 0. I have 3 terms, highest degree 3. So cubic trinomial. If you got both of those correct, then you understand how to classify and write in standard form with polynomials. If you didn't, go back and review the example or go look at the chart on page 371. Now we're going to look at adding polynomials. We've already addressed this a few times this year, but it's really important to be very, very careful from this point on with combining like terms and watching this sign right here between two sets of parentheses. That sign can be an addition sign, a subtraction sign, a division sign, or there could be no sign there at all, which would mean multiplication. So you've got 4 different operations that you could end up doing with 2 polynomials, and every single one you do something different. So you really need to be aware of that sign right there. There are 2 ways you can add polynomials. It's really preference. I'm going to show you both ways, and whichever is best for you, it works for me. Just make sure you're really careful with signs and with combining like terms. Those are the biggest things, whichever way you choose. Notice here we're adding. If we were to distribute a positive right now, nothing here would change. 2x squared would stay 2x squared. A negative 9x would stay a negative 9x, and 1 would stay 1. Nothing changes. That means you can basically just drop both sets of parentheses and combine like terms. So drop both sets of parentheses. You have 4x squared plus 6x plus 7 plus 2x squared, because that was a positive 2x squared, subtracting 9x plus 1. Now you can just go through and look for like terms. So notice here I have a 4x squared and a positive 2x squared, and I always underline the sign that goes with it, because whatever sign that is you need to look at when you combine these. A 4x squared plus a 2x squared, remember when we combine like terms we leave them like they are. You do not make that an x to the fourth. You would make it an x to the fourth if you were multiplying those terms, but you're not multiplying them, you're adding them. So all you do is add your coefficients and you get 6x squared, and then you look for more like terms and notice that I have a positive 6x and a negative 9x. Again, a like term, so it's going to be an x. 6 subtracting 9 is a negative 3x. And then I also have positive 7 and positive 1. And I suggest you do something like this where I'm underlining, or you cross things out as you combine them, because sometimes these get really long and you might miss a term in there. So it's nice to do something that kind of acknowledges you've already taken care of those terms. And then a positive 7 plus 1 more is a positive 8. Check it one more time, make sure. It should also be in standard form. Notice I combined them in standard form. I combined my highest degree all the way down to my lowest degree. And that's the first way of adding polynomials. Now I'm going to show you the second way. Go ahead and write this down. Notice what I did is I just took my first set of parentheses and wrote it here. Second set of parentheses, wrote it here. I don't need parentheses around this because it was a positive. And now I'm just going to combine each set of like terms. Notice how the like terms are already lined up. There are times when one of these is not going to line up and you're going to need to leave a blank space. So if I had something like 4x cubed right here, then the 4x cubed would need to go there, and I would leave an empty space here if there was no squared. And you have to only line up like terms. So you might end up with a term that's not lined up with something else. And then you just add them down. So 4 plus 2 is 6, so I have 6x squared. 6 subtracting 9 is a negative 3x. 7 plus 1 is 8. Same exact answer, 2 ways to get there. Just remember, if you're going to do it this way, you have to line up like terms only. Write these in on the left side of your notes and then hit play when you're ready to continue. It's just talking about how we did each thing here. Just remember you're lining up like terms vertically and combining them. Work through these three. You can try them either way, lining them up vertically or horizontally. If you're going to line them up vertically, make sure you're very careful when you set up the second two, because especially this one, because you might have things that do not line up, that are not like terms. Hit play when you're ready to check them. Since I notice that there's an addition sign here, I'm not going to worry about my parentheses at all. I'm just going to kind of skip a step to save room here. And I'm going to pretend like the parentheses have already been dropped, and I'm just going to look for like terms. So notice I have a 12m squared and an 8m squared. 12 plus 8 is 20. So I have 20m squared. And then I also noticed that I had a 4 and a positive 5, which is plus 9, and that is simplified. Now I move on to the next one. I see a third power and I see another third power. And I knew there was an addition here. You have to be aware of that addition sign. 9 plus 7 is 16. So I have 16 w to the third power. I don't have another w to the second, so I just bring that down, plus 8w squared, and I don't have another constant, so plus 4. And that's in standard form. Degrees is 3, 2, 0. My degree of my whole polynomial here would be 3. So if I was naming that, that would be a cubic trinomial. This one would have been a quadratic binomial. Quadratic because it's second degree, 2 terms binomial. On this last one, again, I have an addition sign, so I know I don't even need my parentheses. So I'm just going to look for like terms. I have a cubic and a cubic. 9 plus 2 is 11. So I have 11p cubed. Then I notice I have a squared and a squared. 6 plus 11 would be 17 p squared. And then I also have a 10p and a 3p, and they were all positive, so 13p. Again, 3 degrees is the highest degree I have in this polynomial, so this would be a cubic, 1, 2, 3 terms, trinomial. Here's our last set of examples for this lesson. Now we're going to talk about subtracting polynomials. And the really nice thing about subtracting polynomials is that you've already really been practicing this idea a lot this year when you've been distributing your negatives. And we've really focused on that a lot leading into this second semester, hoping that once you have that down earlier, it's just going to be a really easy thing to start applying now. So all you're going to do is distribute your negative to this set of parentheses. And once you do that, you can drop both sets of parentheses and you just combine like terms like addition. Only difference there, distribute my negative. Now, I notice there's still a misconception sometimes about distributing a negative. When you distribute a negative, it's not that every term becomes negative. You're actually saying negative times positive, negative. Negative times negative, positive. Negative times positive, negative. So what ends up happening is every term changes its sign. It becomes its opposite. They don't all become negative. Let's go ahead and walk through this example. So because I know I'm going to distribute that negative, I'm just going to go ahead and drop my parentheses as I rewrite this, and I get 2x to the third plus 5x squared subtracting 3x, and now I'm distributing my negative as I rewrite this part. So negative x cubed, positive 8x squared, negative 11. Once I've done that, I go through and I just combine my like terms. So I notice that I have an x cubed here, and I have another x cubed there. Remember, this is an imaginary 1 there, so we have 2 subtracting 1, which is 1 x cubed. Then I look for my x squareds, and I have a couple x squareds, positive 5 and a positive 8. So I have a positive 13x squared. And then I don't have a matching term, so I just bring negative 3x down because there's no like term with it. And I don't have another constant, so I just bring negative 11 down. Now, if we were classifying this, just to help you practice classifying, we have 1, 2, 3, 4 terms. So it would just be called a polynomial because we don't have a special name for 4 terms. But then it's 3 degree. 3 is our highest degree. So this would be a cubic polynomial. The other way to do this would be to line it up exactly like we did the addition as you distribute that negative when you rewrite it. So we have 2x cubed plus 5x squared subtracting, and now what I notice here though is I can keep 3x, but watch what's going to happen when we write our next set of terms. So now, as I distribute my negative, I have a negative x cubed here. It's kind of like when we were doing our systems of equations and you distributed that negative. Then I end up with a positive 8x squared. I don't have an x, so I'm not going to put anything there, but then I have a negative 11. For me personally, I find it more difficult sometimes to line them up vertically because you tend to make mistakes here and then everything looks a little bit confusing. But some people really prefer it that way, so it's completely up to you. Now you combine terms going down, and you've already distributed your negatives, so you don't have to worry about subtracting, you're just doing whatever they are. I have a 2 and a negative 1, which is a 1x cubed. I have a positive 5 and a positive 8, which is a positive 13x squared. And then I don't have anything lined up with that, so I just bring down my negative 3x, and I don't have anything lined up with that, so I bring down my negative 11. Same exact answer, but I solved it vertically. Now I'm going to give you a few to try on your own, and if you're having trouble with it, let me know in class and we can work on it. Write these down and try them. Hit play when you're ready to check. So because I have a negative to distribute, I'm going to need to go ahead and rewrite this. X cubed plus 6x squared minus x, and now I distribute my negative. Negative 9x cubed, positive 7x squared, negative 3x, and now I can look at combining like terms. So I go through, I see that I have an x cubed and a negative 9x cubed. That would be a negative 8x cubed. Remember, there's a 1 there. So I have a negative 8x cubed. I have a positive 6x squared and a positive 7x squared. So that's going to be 13x squared. And then I have a negative x and a negative 3x. 1 and 3, negative 4x. If we're talking about classification, our highest degree is 3, and we do have it in standard form. This is 3 terms, so it would be a cubic trinomial. All right, let's check the other one. Again, I have a negative to distribute, so I'm going to rewrite it. When I distribute that negative, I end up with 30d squared subtracting 30d cubed subtracting 29d squared, subtracting 3d, and now I distribute my negative, subtracting 2d cubed, subtracting d squared. And now I'm going to look for like terms. I have a d cubed and a d cubed. 30 minus 2 is going to be 28. So I have 28d cubed. Then I have a d squared, and I look for another d squared, which I have. Negative plus negative is going to be a negative, and I add them. So this actually becomes a negative 30d squared. Be careful with your integer rules there. And then I have a negative 3d left. And again, third degree, 3 terms. This would be a cubic trinomial.